All right, our solution landscapes, these are the ones with limestone and a lot of water, create an unusual topography, unusual surface features, and subsurface features as well. And it has to do with the presence of limestone, how it reacts with water. Now, we have a lot of limestone in Southern California. We don't get solution landscapes because we don't have a high groundwater table. Our groundwater is very deep, so it's not breaking down the surface limestone like it does in other parts of the country, like the southeastern United States and Florida, for example, which have a lot of solution landscapes. So let me get this going again. Remember when the carbonation process happens, the calcium carbonate in the limestone goes into solution, and so I'll talk about those in just a second. Now this kind of over dramatizes what the subsurface is like, but this is just to give you an idea of how much you can break down limestone in the interior by creating passageways for the water to flow through, voids in the subsurface, all from the rainwater dissolving the limestone. So here we've got a layer of shale. I did it again, I keep screwing up. Here in the Appalachians, we've got some sedimentary rock. We've got this layer of shale that's between two layers of limestone. So the water is percolating down through the limestone, and then it hits this layer of shale that's not dissolving, and so it runs horizontally through the rock until it meets this opening, flows out, goes past the shale, and then absorbs back into the limestone. So this is referred to as a disappearing waterfall. I have no idea what the hell that person's looking at because the waterfall's over here, but there you go. So karst is a name of an area that has a lot of sinkholes. I'll explain what a sinkhole is in an area in a second. So this large area gets an undulating surface. It's sometimes referred to as hummocky, and that's the only time I've ever heard hummocky used to describe karst. It's that undulating, uneven surface. You've got interior drainage. The water often doesn't flow out of the area. It'll kind of sink into the ground and have a lot of subsurface flow. But a single depression is a sinkhole. A whole bunch of them together creates karst. So this is a sinkhole where the weight of the house caused it to fall in. So when you have these subsurface voids that the water dissolved away and removed the limestone, there's not as much to support the rock above it. And so if this void can't support the rock above it may collapse. In this case, the rock above it had additional weight of the house on top of it that pushed it down and caused the house to kind of sink down into the sinkhole. So normally in construction, obviously you'd want to try to avoid this. It becomes a question of, well, how much did you pay did you do any seismic surveys to see if this was a safe place to build or not? And people will sometimes cut corners. Large developers don't. They'll do ground surface radar, and if they see voids and problems in the subsurface, they simply won't build there. And this, so they can avoid this from happening. So usually, though, a sinkhole isn't as dramatic as swallowing a house. You've got just this little depression here where the surface is collapsed. Here we have a whole bunch that creates this type of karst topography where there's a little bit of collapse of the top layer. So this undulating surface near Mammoth Cave in Kentucky. Now, karst can take on different forms. Here, the collapse is significantly more substantial and much more of the limestone has been carried away. And this is, I have a colleague at Cal State Fullerton, Dr. Zia Salim, and he refers to this as crazy karst. And I hope that name catches on someday. That's clearly, I mean, they're both the same thing, where the limestone gets carried away by water, but this is clearly a little more dramatic than this. Karst actually gets its name from a region in Slovenia called Karst, and so this is Karst, Slovenia, and karst topography is named after Karst, Slovenia. There's other types of karst. You've got karst towers in China, but again, this is just simply creating a solution landscape of the limestone being dissolved away by the water. Now, if the water level drops, those subsurface voids become empty space, no water in them, just simply air. And this is when you get caverns, caves and caverns. I love caves and caverns. This goes back to when I was a kid and we'd be on vacation. My dad would like, there's a cave, we're going to stop there. So I've seen all the weirdest caves in the Western United States. God, I'll never be able to remember them all. Carlsbad Caverns, Moaning Caverns, Mitchell Caverns, Mercer Caverns. There was something up by Lake Shasta too, but it was always fun for me. And so, dude, this little part of the lecture always brings back nice childhood memories. All right. So, when you've got this limestone here, the water is you're still getting rainfall, so the water percolates through the soil. But this water, as it percolates through the soil, picks up some of the lime in the water, in the rock. And so, when it drips from the ceiling, it leaves behind a tiny remnant of that lime. And then when it splashes on the floor of the cave, it leaves behind a little bit more lime and then it flows away. So over time, every time it drips, leaving a piece and then it falls, you get these features kind of hanging down from the ceiling. And then when it hits the floor where it splashes, you get these features that build up from the cavern floor towards the sky. So the feature hanging down from the ceiling is a stalactite. It's holding tight to the ceiling. A stalagmite comes up from the floor. And there's a cheesy way to remember it that I never got because it says stalagmites. It's got the M, so the M goes up, and then the stalactite has a T, and the T points down. But it always confuses me because there's T's and stalagmites. So whatever. The way I remember which is a stalactite holds tight to the ceiling. If you say a stalagmite holds mightily to the ceiling, it sounds stupid. So they all take on different colors and shapes because no cavern's the same. How are there other minerals in this limestone? Are they getting a lot of rainfall? Not a lot of rainfall. Are there a lot of joints? Because joints will affect where the water comes down. So you may get an area where the water is all concentrated in one place. Maybe here it's along a linear feature. Some places will get more than others. So they're kind of inconsistent, which kind of makes it interesting and colorful from one cave to the other. So Carlsbad Caverns, this is the big one in the United States. It has the largest void in the subsurface. I don't know if it's in the world, but it's one of the largest ones. It's definitely the largest one in the United States. It's not the most expansive cave system. Mammoth Cave in Kentucky covers a larger area, but it's really difficult to get through. They don't have the large void that Carlsbad Caverns has. Now, I'll probably come back to this later, but the Americans are terrible at naming things. So there's that giant void in the Carlsbad Caverns that is literally 1,000 feet or more across. And if you bend it a little bit, you're almost at 1,500 feet. Put a 5-story building in here. And so that room is really big. So it's called the big room. So Carlsbad Caverns, since it's a national park, it's ADA compliant. So they've got this nice ramp working their way down into the cave and then a trail. And when you get underneath at the bottom, there's a cafeteria. There's an elevator that'll take you back up to the visitor center. One of the odd things about it, though, since this was kind of built and developed in the 1930s, our attitude towards environmental preservation were different then. So they put bathrooms down there, so right up against the cave wall. For a while, they had talked about removing them and trying to restore it to what it used to look like. And then it was pointed out that you're going to take something unnatural and replace it with something unnatural. So just go ahead and leave it. The colors in here, they only use white light, so any greens you see are the rock color and not the lighting. The cafeteria, admittedly, is a little hokey. This was redone in the 1960s, so it's got kind of a 1960s architecture about it. The reason they have a bat is because there's bats in parts of Carlsbad Caverns. I like it. I think it's kind of funky. Now, our hydrothermal features, these are related to solution landscapes because we're getting the water, the heat of the water is dissolving rock. And so when it's brought up to the surface, it's creating a new feature as well. So like I said before, we get our hydrothermal features when we're near a heat source. So they're typically associated with either ancient volcanoes or current volcanoes. But we have to have a heat source to get the water hot. Geysers, sorry, I'm exasperated. The process, I'm not going to test you on the process. I'm going to go over the process, but I'm not going to test you on it. But when the water in the subsurface is hot, it's going to break down the rock, especially if the water is a little bit acidic. And this is going to vary depending on the rock. And hot water will actually dissolve some of the quartz in the rock and create a silicate. It's a type of rock that has a high silica content in it. And so geyserite is a silicate. It's not pretty and colorful. Usually it's kind of this grayish color. It depends on what it's passed through. So sometimes when it passes through limestone, it may pick up a little color. But for the most part, it's kind of this grayish color. So the buildup of subterranean pressure, what usually happens is you've got a water source feeding into a subterranean void. And so the water's feeding in here, and it's not, as it builds up the pressure, it changes the boiling point of water. So the higher the pressure, the higher the boiling point of water is. And so at some point, the pressure builds up so great, but it finally reaches its boiling point. Once it boils, the pressure releases. And so all of this, since it's at a lower pressure, boils instantly. And when it boils instantly, all that steam and water just gets pushed right up to the surface. Different geysers have different plumbing systems down below. So they're kind of inconsistent. Some erupt every couple of years, some erupt almost continuously, some are on a regular basis, like Old Faithful in Yellowstone. So there's a lot of variations in the subsurface for how often geysers erupt. So Old Faithful in Yellowstone, this one has what's considered a relatively consistent plumbing system in the subsurface. And so when the pressure builds up and it releases, based on how long this erupts, they can calculate in time when the next eruption will be. And they'll post it and everybody gathers and shows up, and then they all disappear, and then until the next posted time happens. Now, Yellowstone is the highest concentration of geothermal features in the world. It sits above a large magma chamber. It's actually a hotspot. And what happened was this used to be a large volcano, massive eruption. And when it erupted, it blew the entire top off the volcano, even more so than what happened at Crater Lake. And so this central area, the Yellowstone, where the Yellowstone Park is kind of a basin. And so it collects water over a large area. The next graphic shows it a little bit better. It collects water over a large area. And so normally when you have a mountain, the water would flow away from the magma chamber. But here, since we removed the top of the volcano, the water can collect towards the magma chamber, get heated, and come back up to the surface. Now, the volcano that came up that created Yellowstone was coming up through sedimentary rock. And so when the top of the volcano blew off, it was a combination of volcanic rock and a lot of sedimentary rock. So there's sandstone, limestone, and shale in here. And that will affect what the geysers and hot springs look like when they come up to the surface. So here you've got an area where the hot water is percolating up through limestone, and it dissolves the limestone and then redeposits at the surface. So remember the million ways to make different types of limestone, and here's but another way. And travertine is limestone, but it's unusual because it was formed with hot water. It's a really dense form of limestone, because you use travertine as a tile when normally you can't use any form of limestone as a tile, but travertine is relatively dense. Here it's not quite as colorful, and the flow spread out different area and killed all these trees. The hot springs here, we don't have a geyser, we just have a constant flow of water to the surface. Typically, the deeper and darker the color, the hotter it is. So this is probably around 200 degrees, and this outer area here is around 150 degrees. Again, over 130 degrees is enough to give third-degree burns, so they highly recommend caution and safety and no swimming in these things. But people are stupid and they're constantly falling in or doing something where they're burnt or dead in the process. If you do fall into one of these, you've got third-degree burns over 100% of your body. They take you to the hospital, fill you full of morphine, and wait for you to die. There's actually an entire book about how people die in Yellowstone, and my sister and I are strangely fascinated with these types of things. But a lot of these are related to accidents that happen in the hot springs and just people ignoring the signs. There's an equivalent book for Grand Canyon, for Yosemite, for Glacier National Park, and one of the common threads is typically males and alcohol, which is an odd combination that hardly ever happens. All right, so back to our hot springs. So again, watch your kids. They tell you to stay on the trails because you don't know if there's a subsurface void that you could fall through and die. Again, the colors from the chemicals coming up and the microorganisms in it, giving these different colors. This place is spectacular. Other than the smell of smelling like sulfur, the place is just so colorful and so beautiful. There were some asshole YouTubers who took some pictures out on here. They've been banned from national parks for life. They had to pay a large fine, and they could have died in the process. But gee willy, they got a neat YouTube video out of it. All right, our next video will be mass wasting. Take care. See you later.